Right, question one is looking at a survey, and Dan, what's he done? He's surveying people to find out how much time students spend playing sport. He's going to ask the first 10 boys on the registers for his PE class. Explain why this may not produce a good sample. Well, a couple of reasons. It's biased by gender, only selects boys. Also, it's biased because boys, of these boys even, these boys may have chosen PE, so it would be more positive. So there's two reasons. Other acceptable answers, the lines of sample could be too small, it's not random, it's gender, age as well, because it's a single group. So all those are acceptable. Design a suitable question then for B. For Dan to use in a questionnaire to find how much time students spend playing sport. How many hours? And I'll put to the nearest hour, you'll see why in a second. Do you spend playing sport? And then put your time frame in, so in a week. Now the reason I put hours is because it's easier then, because you're then dealing with just discrete data. So I can note to no hours at all, 1 to 2 hours, 3 to 4 hours, 4 plus hours. Okay, question 2. Got a scatter graph another day. There were 12.5 hours sunshine and 73 ice creams are sold. Must be exactly 3 squares higher. Can't be near, it's got to be exact there. Then it says describe the relationship. So question 2A is done. Question 2B. The relationship is as hours of sunshine increase. So as hours of sunshine increase, what happens to the ice cream sold? They also increase. Ice creams sold increases. Positive correlation on this, you're not going to get, well, you may get the mark, but to be honest with you, you need the actual statement in there, so don't bother about correlations. If it asks for a relationship, unless it asks for correlation directly, talk about the two variables. One day had 10 hours of sunshine, estimate how many ice creams are sold. So we go at 10, we go up into the data there, and then go across. Probably slightly over-egged it there, but I'm going to go for 65. Acceptable here is from 62 to 70. Right, question 3. We've got 2 parts. Part A first of all. We've got a ratio of number of freezers to cookers, so we've got F to C. Freezers are 5, cookers are 2. Shop sells a total of 140 freezers and cookers in 1 week. So we want to work out how many were sold of each. So the first thing we do is work out we've got 7 parts to share them into. So we've got 140 there divided by 7. That gives you 20. And then you times your 20 into both of these. So 20 times your 5 is 100. And 20 times your 2 is your 40. So there are 100 freezers and 40 cookers. B, work out how much Jake saves. So original price was this, reduced by 20%. So 10% then is £14.50, and double that, 20%, is then £29. Now a lot of students then will take the 29 off this to work out how much he pays. It's a swine of a question this, but it's only looking for the amount that they saved. If you have taken one off the other, then you'll only score 1 mark, unfortunately, even though you've actually got the right answer and you're working. So just put 29. Question 4. So we've got a box then, first of all, because this is a two-way table question. You can sort of see by the way it sort of looks what sort of question we're looking for. We've got teachers, students, school lunch, packed lunch if they went home, and then we've got boys and girls. So what we're going to have here then is I'm going to put boys and girls down the side here. So boys and girls and save a space for total, and then we're going to go upwards. We're going to have school lunch, packed lunch, and also go home. So we've got school, we've got packed, and we've got home. That's the total there. And we've got boys and girls. Now we know from the first line that there's 30 students in total there, so 30 goes into that corner. And then we start reading it. So 17 students were boys, 4 of the boys had a packed lunch, 7 girls had a school lunch, and 3 of the 5 students who went home were boys. So 3 of the 5 students that went home were boys. We then put down what we can work out. Well, 4 plus 7 is 7. Sorry, 4 plus 3 is 7, so you've got 10 left there for the boys. 3 plus something gives you 5, which will be 2. 17 plus something gives you 30, which is going to be 13. And then 7 plus your 2 is your 9. Add your 4 on, that'll give you 13. 4 and 4 is your 8, and then 7 and 10 is 17. And add these 3 up as a check to give 30. Therefore, you know that's right. And it wants the number of students who had a packed lunch, so then you'll just write underneath 8 had a packed lunch. Question 5. So we're on here. We've got probability that a seed will grow is 0.85. Planted 800 seeds. How many will grow into flowers? Well, you take your probability, times it by your number of seeds, and that will give you your number of seeds you'd expect then to grow into flowers, which is 680.